Hello everyone. It's been a while since I've done a weather video, but I figured I would take an interest in this weekend's storm. Um, so I'm just going to get right into it. I tend to talk a lot. Let's try not to do that this time. Um, what you're looking at here is the 500 millibar vorticity map, which shows the shortwave energy, the troughs and the ridges in the atmosphere. So those of you who are familiar with meteorology know that when it goes up and down like that, that's called a ridge, and when it dips down and comes back up, that's a trough. And when we want storms along the coast, we are looking for troughs like these here to bring northern jet stream energy southward and merging with southern jet stream energy to create these big coastal storms that then come up the coast. And that is what's going to happen here, it looks like. The first thing I want to show you is this is today's run. This is for about 1 a.m. on Saturday morning, what it's going to look like in terms of the 500 millibar vorticity map. And I just want to compare this run to the run from, I think this is Sunday, if I am correct. What I want you to notice here is you have, without going into too much detail, you have all this northern jet stream energy here that is not consolidated with this other shortwave energy that extends into the south, and this energy is all strung out. It's very weak. It's not very strong. So this is all the northern stream energy it's not digging to the south and it's not phasing and creating a strong system. So this is what the run looked like back on Sunday. And then out here, if you see, you have all these pieces of energy from the southern jet stream, which is what's going to create the storm. And it's not consolidated so that this northern stream energy is not strong enough to contain the southern energy and keep it from going out to sea. So earlier this week and into this past weekend, this energy, this shortwave energy in the southern jet stream was just going out to sea after developing the storm, and we weren't getting a coastal storm because this was weaker and not consolidated. But if you go to today's run, obviously it looks a lot different. So all that energy, shortwave energy that was back in here, not consolidated, now is consolidated, and it's digging much further south. So now because this shortwave energy is a lot stronger, it's merging with the southern stream energy here. It contains that and is able to consolidate with it to create a strong coastal storm off the Carolina coast that will go up into the Canadian Maritimes. So because of the consolidation of energy now over the last couple days, that has become the pattern. This has now created a stronger storm, which has tracked further and further west with each run. And I feel like that trend is going to continue. I just have a feeling based on the way this is looking now. It could go the other way, obviously, but I have an intuition that this is going to end up being a good storm for somebody along the East Coast or inland if it comes further enough west. The other thing I want you to notice is that I and other people often talk about the tilt of the trough. So the trough axis here is neutral to going slightly negative. And back on Sunday, there's not much of a trough to begin with, but you can see that it's more positively tilted from northeast to southwest. When it's positively tilted, you have weaker energy and the southern energy goes out to sea. But in the newer runs, the tilt of the trough is now north-south or northwest to southeast, so it's going from positive to neutral to negative, and that allows the flow out ahead of the short wave itself to push the southern stream energy up the coast rather than out to sea. So that's basically what's happening here. So now let's just go through this real quick. So just pay attention to this. It's going to consolidate here, and this is going to take on a hook-like shape. And whenever you see a hook-like shape like that in the vorticity, that usually means you're getting a pretty good nor'easter, as long as it's neutral to negative. And as you see, going into Saturday morning, this is still very negatively tilted. Here's the southern stream energy. It's not out to sea. It's right at the coast here. So you're going to have your storm out here. Going ahead, you see that it starts to get stronger. It's starting to phase with the northern stream energy, and it's really taking on a hook shape. So the whole system is strengthening as it goes up the coast. And then eventually it's going to close off, which is the closed isobar. So it closes off a little later than I'd like, but is still closing off. So all this energy came together, and so based on this, we're going to get a pretty good storm. So now let's look at the surface map. Let's go back here. By the way, this is the 18Z run of the GFS. Okay. I could, by the way, show other maps like the jet stream and the vertical velocity, but to keep it simplified, I'm just going to stick to the 500 millibar vorticity. So let's go here, and there it is. So your storm forms actually pretty further south than I expected, because actually that trough did dig pretty far south. So it would form off the coast of the Carolinas and Georgia. Notice that we were at 1,012 millibars, and that's important because notice how quickly we're going to drop in pressure as this low moves up the coast. So here we go. Now we're at 989 late Saturday night. We're off the coast of North Carolina. Notice that you are starting to getting snow across North Carolina into Virginia, but I don't really think this is going to be quite heavy yet. I think it gets heavy when we get towards Saturday morning, and then you're going to see starting along the coastal areas here, Virginia, Delaware, and Maryland. That's where the heavy snow starts late Saturday night. And then it starts to move into coastal New Jersey, Long Island, New York City Saturday morning. And then it goes up, and now we're down to 975. That's a 25. I'm trying to do this in my head. That's a 37 millibar drop in pressure. So that's very rapid strengthening. That's called bombogenesis or bomb cyclogenesis of a low pressure system. And what I want to point out, the European model has this flow a little further west, and I think the NAM might as well. Actually, I don't know if the NAM goes out this far yet, but the Euro has it further west and even stronger than 975. I'm not sure I buy that. I can buy a 975 millibar low, but I don't know if I buy a 966 millibar low. But what I want you to notice here is this low is close enough. Also, the other thing to notice is since the low is going to be closing off, I don't think you really need to worry too much about mixing, even along the coast, because when the low closes off, precipitation gets a lot heavier, and you have evaporative cooling, which will cool the air even close to the low pressure system. That is, as long as it stays off the coast. If it comes inland, then you're going to get mixing and rain. But for now, it looks like this is going to be mainly snow event for everybody. And the main thing to notice is this darker blue here. I think this can come further inland. I think the precipitation shield in general can come back almost into the west of the Catskills, maybe not quite to the Adirondacks, but pretty close. I think it can come back into eastern Pennsylvania and then back into central Maryland as well. I think the precipitation shield can come back that far for at least the lighter snows. And then I think the heavier snows can come further back into central Massachusetts, Connecticut, lower Hudson Valley, New York City, Long Island, and into coastal Connecticut, and maybe down into coastal Delaware. The GFS tends to underdo precipitation in these storms this far out. So if the low takes this track or even further west, I think that heavy snow is going to come into those cities. So Boston's definitely in it, and then New York City would be in it. Philadelphia, I would say, has a chance. DC probably not, but you never know. So cities like that, and then Albany would probably get the lighter side of the snow. But I think the precipitation shield can come back like that, and then the low continues to strengthen, and it moves to the northeast and such, and then it's out of here by Sunday morning, Sunday afternoon. So I'm not going to do accumulations yet. It's way too early for that. Let me see if I can get my snow map up. So this is the threat field that I created. Note that I take the threat further back than the models do right now, only because the western trend has been pretty strong with most of the models, and I have a feeling that's going to be the trend going forward. So let's just call this the threat for heavy snow area. I don't know about accumulations yet, and I'm not going to project accumulations yet because it's too early. So let's just call this the threat for heavy snow. As I mentioned, the GFS doesn't show it, but I think the snow shield can come back into eastern Pennsylvania and central and eastern Maryland. I think it can come back into the low Hudson Valley. Maybe not back into the Adirondacks, but I think that at least the light precipitation shield could come back that far. But if the westward trend continues, it could come back that far as well. I think all of New England has to be in the threat region right now. I think anybody east of New York State is at a pretty good chance for heavy snow right now. So Boston would be included, all of Maine, New Hampshire, Vermont, Connecticut, Rhode Island, and New York City would be in the threat zone, and Philadelphia would be in the threat zone as well. So that is my thinking for now. Probably not going to have accumulations tomorrow either, but we'll see if I have to adjust this map at all. Again, this is further west than the models have right now, but I think that there is a decent chance that the heavy snow shield can come back further than the GFS has it right now, just based on the strength of the storm and the strength of the 500 millibar vorticity map that I'm looking at. All right, thank you for watching. I'll be back tomorrow.